Hello everyone, welcome to my YouTube channel. In the lecture of class 12th, today I will start the binary operation. This is the last topic of your first chapter, that is relation and function, and it is a very small topic and very easy topic. Okay, so let's start the topic, that is binary operations. Operations, it takes the definition like this. Definition is the binary operation that is denoted by the stars on a set A is a function, that is a function that taken from A cross A to A. Okay, we denote star of AB, two elements AB by A star B. Okay, we always take the binary operation by the using star operation. The A star B is the binary operation. This is the way to write a binary operation. Okay, now come to the first definition. There are two type of binary operation. First is commutative, second one is associative. Okay, in the two element, if we talk about the two elements, that is A and B, so that is the commutative property, and the associative property is only for three elements. We have to take three elements for the associative property. So let's do the definitions of commutative and associative. A binary operation star on the set X is called the commutative. Commutative if A star B is equals to B star A. For every AB belongs to this set. Okay, so this is necessary to prove that A star B is equals to B star A. That is a commutative property. Now come to the associative property. If the binary operation is from A cross A to A is associative only if it is applicable. This equation, if the binary operation satisfies this equation, then it is said to be a associativity. Matlab that binary operation is associative. Okay, that means you have to prove the binary operation on these two. After using the value of this, we will do the binary operation with 3, that will equals to the right hand side. By using these two, we will do the binary operation with A. Okay, now there exists the identity element also in the binary operation. How? That by using this identity. Okay, by using these values, there is an identity element for the operation. If A star E, this E is the identity element. This will never change the identity of A. Okay, that means E is the identity element in this binary operation. Okay, now the last is inverse, the existence of inverse. Yes, the inverse of a binary operation is also exists if the function is invertible. If A belongs A, with the identity element A, there is one element which is invertible, has the inverse. That is find out by using this method, in which the B is the inverse of A and it is denoted by A raised to power minus 1. Okay, so this is the introduction of the binary operation. But how we can solve the question of binary operation? Let's start. Before starting the questions, I will tell you one formula, that is number of binary operation. How we can find the number of binary operation? There is one formula. Come to that formula. By using that formula, we can only find the numbers. Okay, only find the numbers by using that formula. What is that formula? Let S be a finite set with an element. Let S be a set, finite set. We can write it as finite set, not infinite. Finite set consisting an element. Okay, and elements. Then S cross S has n square elements. N square elements. Then number of, how we can number of binary operations of S. Binary operations is equals to, that is, this is number of binary operation. What is that formula? N raised to power n square, n raised to power this square. That means the number of binary operation depend on the number of element present in that set. Okay, so let's do the questions so that you can easily understand the concept. I will take the question from your CBSE exam. Okay, so let's start the questions. My first question is, I will do the question for you of each topic: commutativity, associativity, binary operation, identity element and inverse. Okay, so let's start. I will take the question from your CBSE exam. First question is, it comes in 2012. Okay, the question is, let star be the binary operation. Binary operation given by a star b is equals to LCM of a and b. Find 5 star 7. So how we can find 5 star 7? This solution is very easy. A star b is equals to LCM of a comma b. 5 and 7 behave like a and b. Only say operate these two elements like the given operation, binary operation. That means LCM of 5 comma 7. When I take the LCM of these two, 5 7s are 35. So this question comes in your CBSE exam in 2012. One more question that comes in 2012. What is that question? Question is the binary operation. The binary operation that is R star R cross R to R is defined as A star B is equals to 2A plus B. Find last is 2 star 3 star 4. You have to find the value of this function. The function, when the questions is given, the value of the question, that means real number is also given. Here the number is a and b, both belongs to the natural numbers. Here both numbers are belongs to the real number. We will do the operation by using this binary operation which is given to you. How we can solve? A star b is equals to 2a plus b. For finding this binary operation, first of all find the value of 2 star 3. I will put the value of a and b as 2 and 3. 2 into 2 plus 3, that is 2 2s are 4 plus 3, that is equals to 7. Now I will use, for finding this operation, I will use the solution of 2 star 3, that will equals to 7. I will put the value of 7 star 4. Now behave like a and b in this question, in this operation. 2 into 7 plus 4, that is 14 plus 4 is equals to 18. So this is the way to solve the question of binary operation. These questions are very easy. The introduction of binary operation is given to you and the numbers are given to you. You have to apply the numbers in place of a and b. That's all. That is no difficulty at all for finding the binary operation. Okay, now come to the question of associativity and commutativity. So let's do that questions of associativity and commutativity. Okay, so I will take the same example for commutativity and associativity. So I will take the question like this. What is the question? Question is, discuss the commutativity. Discuss the question of commutativity and associativity of star on R defined by A star B is equals to AB divided by 4. Okay, for all AB belongs to R. Okay, so let's do this question. This question is very easy. We have to check Is it commutative or not? Is it associative or not? Okay, so let's start. Take the solution, that is A star B. We have to prove AB upon 4, then B star A. Now take B at the first position, BA upon 4. But the product says that AB equals to BA. So then we can do it as A star B is equals to B star A. That means star is commutative. Okay, now we have to check for associativity. That means for associativity, we have to prove. What is we have to prove? A star B star C is equals to A star B star C. Right? So I will start from the left hand side. When I take left hand side, that will A star B then star C. I will apply the formula here. First of all, I will take the same identity AB divided by 4 star C. Now this full term behave like A. Okay, so this will equals to A into B divided by 4. So AB divided by 4 into C divided by 4. That will equals to ABC upon this 4 comes down, 4 4s are 16. Okay, now I will take the right hand side. Right hand side is equals to A star B star C. That will A star this BC upon 4. Now the full term behave like as B. Okay, I will apply the formula for this term also. A and A into BC by 4 divided by 4. Now you have to take the product of this and this value comes down. It will equals to ABC upon 16. This implies this value A star B star C is equals to A star B star C. That means both are equal and the star is associative. Okay, so we have associative binary operation as well as commutative binary operation. This operation is binary operation, that is commutative as well as associative. It is not compulsory that all the binary operations are associative as well as commutative. Okay, it is not sure that they are both. Both properties are applicable in every binary operation or not. Okay, it is not sure. It may be okay for like commutative or associative. It does not be, or it does not obey this associativity or commutativity. It totally depends on the binary operation which is given to you. Okay, so let's start the question of identity and inverse. So we have the identity element. How we can find the identity element and inverse? For finding the inverse, the method of finding the inverse is very simple. Method for finding the inverse. How we can find the inverse? First of all, finding the identity element. What is the, how we can find identity element? Question of 2012 again. If star is defined on the set R0 of all non-zero real numbers given by A star B is equals to 3AB by 7. Find the identity element. Find the identity elements. So you have to find the identity elements by using the properties which I have told you in the first page. Okay, so how you can find the identity element? For finding the identity element, you have to write the property, that is A star E is equals to A is equals to A star E is equals to A is equals to E star A. In this equation, E is is the identity element. You have to find the value of this E. Either you can take the first portion or you can take the second. From these two portions we will get the same value. Okay, so let's start this question. A star E. So I will take the operation A star E equals to A, only taking the left hand portion. So we have using this binary operation E, we will put the value of B, E in place of B. This is 3AE upon 7, that is A. A and A will cancel, E is equals to 7 by 3. Okay, if I want to start from this side, the answer will remain the same like this. A is equals to 3EA upon 7. A and A will cancel, E is equals to 7 by 3. From both sides we will get the same value. So identity element is element is equals to 7 by 3. So this is the identity element. Now I will do one question of inverse for you. For finding the inverse we need the identity element. So let's do that question, that is depend on the last property which I have told you. That is the how you can find the inverse by using that question. Find the inverse and show that it is invertible. Okay, this question is also very easy. How you can find the inverse? The question is on Q naught, the set of non-zero rational number, the set of non-zero rational numbers, star is defined by A star B is equals to AB divided by 5. Okay, for all AB belongs to Q naught, find the identity element. And prove that every element of Q naught is invertible. How we can show that it is invertible? We can find the inverse. If the inverse is according to Q naught, we can say that it is invertible, and that is the inverse of that binary operation. But for finding the inverse we need identity element. Okay, so let's start with the identity element. First of all we have to find identity element. Okay, so I will start with the identity element, that is A star B is A star E, that is the identity element, is equals to E star A. I will take only this portion to find the identity element, that is AE upon 5 is equals to A. This A and A will cancel, E is equals to 5. This is the identity element. Okay, this is the identity element. This is the first part which is you have to find out. For finding A star B is equals to E is equals to B star A. This B is the inverse. If I can find the value of this, the full function is invertible, otherwise not. I will put the value of AB upon 5 is equals to, that is the value of A, that is 5. Then B is equals to 5 5s are 25 divided by A. If A is not equals to 0. If A is not equals to 0, that means Q naught, the set of all non-zero rational number, that means it is the inverse element is equals to 25 by A. That means thus every element of Q naught is invertible. Q naught is invertible and has inverse and has inverse. What is the inverse of that element? That 25 by A. So This is applicable for a non-zero numbers. So this is the way to solve the identity inverse, associative and commutative. Do the practice of these type of questions. Okay, this is very easy topic. You have to do the practice. This is a very easy concept. Okay, do the practice. Thank you.